Right, get into this. This is a talk just called So You Want to Make a Game? It's just kind of going through the general concepts of making a game. So actually, being the ideas person, doing the design aspect of things, implementation, which is going to cover C# and, well, more over just like text-based, but also visual scripting. So it's going to be super introductory. Let's get into this. So. Uh, Hi, my name is Tori. I'm a technical designer. I'm just due to start at Playground Games working on Fable. I just finished a master's degree at Staffordshire University. I've got a big love for arcade games like Point Blank, Katamari, a lot of horror games. I also like to do photography, music, and art, and I run a very small development team called Nest. And we're working on a full version of the game you see there in the bottom right. I also do videos on YouTube, so if you are interested in game design, I do have a few different ones. My next one's actually on 3Cs, which I'll get into in this talk as well. This talk is both for newcomers and for veterans to game development. For veterans, just hopefully in case you can understand someone else's processes and methodology. So, the way I do things might be different to the way you do things, and maybe that's just interesting, but for newcomers, this is definitely going to touch a lot of different bases in ways that should hopefully be pretty straightforward. The talk is for designers. It's kind of for artists. I wouldn't say it's like entirely for artists. It's more for just game devs in general. And it's for both hobbyists and people who are looking to do it as a career. What it's not about resumes. It's not about getting a job in the industry. I won't be doing information overload, so I won't be going super into depth on concepts. So if you are here hoping that the programming or design will go super complicated, I won't be doing that, unfortunately, or fortunately, dependent on the way you see it. And I will not be going over any business or marketing in this talk. So we'll be going through game concepts, your design, your development and art and polish finally, including game audio, and then just kind of closing things off for questions. Okay, so part A, game concepts. You're probably wondering at this point, like you say you've just started making your first game, where do I start? So where you really want to start is with your game essence statement. A game essence statement is effectively just a single sentence which summarizes what your game is before you actually know what you're making. So a few examples of this. These are ones that I've just typed up myself, but based on some games that I like, Animal Crossing and The Last of Us. You can see here from both of these paragraphs that it basically outlines exactly what you want the game to be, on the assumption that you don't know what it is yet. Almost like you write a little poem or a little paragraph. I think it's enough, really. So, what you really want to do when you're making your essence statement is look to kind of start with a few simple keywords, or even brainstorm. So if you've got an idea for like a horror game or a survival game or something like that, you just start with, I want it to have crafting, I want it to have this, and then you just kind of branch out from there until you have like your idea. Analyzing games is a critical skill that I would recommend getting into. So don't just play games as a player, try to look at them more as a designer. You don't have to look at the super complex things, but just understanding in, for instance, level design, why things are placed a certain way, understanding why something feels good to you as the player. And then you kind of really get an idea of exactly what you want to be doing from that point. You might hit creative block as well, but that's completely fine. Everyone hits creative block across the industry. I've spoken to people at the Yuki conference that said they hit creative block, and they were like lead programmers and lead designers, so it happens to everybody, don't worry. You can also get inspiration from outside of games. Ironically, I'm just going to say touch grass here. I know it's a dead meme. Go out into the world and look for inspiration. The game I'm working on at the moment is actually inspired a lot by nature, and I like to go out and take a lot of photos in nature. And I used to do a lot of like mountain climbing and stuff. So like you will find inspiration everywhere, whether it's in a horror film or it's in your favorite album or it's just like down your street. There's inspiration absolutely everywhere. The games, Pokemon notoriously are invented because the game director of the original one was inspired by collecting bugs as a child. So that guy didn't even play a game, and yet created one of the most influential games out there. So it happens. Specifically referring to Katsuya Iguchi here as well. This is just an interview with him. He is the original game director and creator of Animal Crossing. He took inspiration from basically moving away from his family and friends to start his job at Nintendo and realizing how lonely he was. So the entire game is actually based on his own experiences, trying to reconnect with a community. So, what is the experience that you are trying to create for your players? That is something super, super important to consider. You've got to think about it from the angle of player expression or having a completely rigid experience. And by that, I effectively mean something like Animal Crossing or The Sims is entirely about what the player puts into that game. The town looks like they want it to, the character looks like they want it to. On the complete other side of that, you may get a game like a narrative game. So if you think about the Dark Pictures anthology or Until Dawn, they are a lot more rigid as an experience. You play as set characters and you go through that experience. Although there is also player expression within that as well. And in the fact that you still make choices and you still kind of influence the ending of that story. But that kind of goes to show it's a sliding scale. It's not really one or the other. You can have instances of player expression in a rigid experience and vice versa. So going back to the essence statement, you basically have your dissected essence statement, and then you will formulate it into your systems and mechanics. And as an example of that, here it is in Animal Crossing. So this is the one that I wrote before, and as you can see, each individual part of that is therefore a mechanic in of itself. So it's kind of cheating since I did write this after the game existed, but it's all the same either way around that you do it. It gives you a very good holistic understanding of what you want your game to be before you've even put pen to paper, really. So I recommend it. Once you've got your mechanics taken out of your game essence statement, you can actually begin to understand what is considered a system and a mechanic. So for instance, oh, I want my characters to change their clothes. I want my characters to be able to use different items and stuff. And then you begin to realize, oh, that's all, player customization. So that's all part of the player customization system. And likewise for relationships, you might have a few mechanics there, and they would then go into that bracket. You can begin to make a bubble chart here. For this slide, I haven't done that, but basically you want your game, then your systems, and then your mechanics. You can also have systems inside of systems, but for the sake of simplicity, we'll just leave it at this for now. And here is an example of how you would do that. When I've done this myself as an exercise for understanding exactly the scope of my game and like what my game is, it does get a bit crazy. It's great to have more ideas than you're going to use than have less ideas than you're going to use. Because the worst thing you could really do when you're making a game is adding ideas at the last hour. You really want to be thinking about your ideas from the start. So again, you do have that holistic vision when you've actually got a full game at the end. So here's just me actually detailing my own mechanic and my own system. So the hub area being the system and the features and mechanics being parts of that system here, and showing my inspirations as well. I've got the Minish Cap, I've got Stardew Valley, and I've just got kind of Danish hygge vibes, which is a very famous cozy core thing at the moment, or popular even. And you can see how I've actually distilled and formulated those aspects into the one on the right. So you've got your upgrade cards, you've got your access to caves off the right of the screen in that top screenshot. You've got your characters, you've got really everything that you need there. And that only really came to be well-rounded, I would say, as an experience due to the fact that I had the documentation and the planning ahead of time. So I know I'm just repeating myself here, but I think it's really important to iterate how important that is. Going back to scope, be wary of scope and feature creep. Like I said, if you have your features introduced much later on, that's not particularly fantastic. So you just kind of want to make sure you get your features in early, and then do something which is referred to as design by subtraction. Fumeto Aida, who did the Shadow of the Colossus, Eco, and The Last Guardian, I'm not sure if anyone's heard of those, they're first party, or second party, sorry, Sony games. But what he did was originally started with a much larger experience in the beta version of that game and in the planning stages. I think originally there was, I think, 32 colossi, which are like the big bosses in Shadow of the Colossus, and were cut way down to 16. Eco had a much more established combat system and was completely brought back to being just waving a stick around. So there's a lot of different ways that you can cut a game back. And the reason that is done is because it makes the experience more perfected. Antoine de Saint-Exupéry, who is the guy who did The Little Prince, actually once said, perfection is achieved not when there's nothing to add, but when there's nothing to take away. So I think that's a really good way to kind of look at your game planning from an early thing. You don't want to just be adding absolutely everything and having like a Homer's car experience. It's so much easier for you to have something that's succinct and feels like it's exactly everything that it needs to be. Another way that you can do planning as well, besides doing the charts that I showed before, is using something called a Moscow list, which means must have, should have, could have, won't have, and you just basically stipulate exactly what you want in your experience from a more game design point of view, really. So you can do this later anyway, or you can just do it instead. It doesn't really matter. This is one that I did for a project, and it turned out pretty well, but I will say that for this I didn't actually focus on it, which is one thing that I will definitely say that I learned from that was always make sure you're looking at your Moscow lists and looking at your plans so that you're keeping that focus. You don't want to start to stray too much from your original vision. Otherwise you end up with the Homer's car. So going into game engines, which one is right for you? There's obviously these four here, but there's also a bajillion more out there that you can use. The reason I've specifically included these four is because they're kind of the main four which are publicly accessible to anyone for free. And also because they kind of strike two different notes each. So you've got the designer-orientated ones on the left. They're very easy for scripting. They have their own visual scripting languages. They're very visually easy to read and kind of easy to pick up as a beginner. So at the start of university, I had a lot of Unity experience already, and I'd come in to learn Unreal Engine. And I was trying to look at it with like a programming brain going in. I was like, oh my God, what am I doing? But then I realized, you know, it's all good. Everything's so simply laid out there, and it's actually quite efficient to like learn as your first engine. So I'd maybe even recommend that for anyone's first engine. Game Maker Studio 2, Undertale, Hotline Miami, games like that were made in it. They were made because the people who made them didn't have much programming experience. So then again, Unity, I would say, is a bit less user-friendly since there isn't really anything in the engine to start off with. Just to explain as well, an engine is effectively just all the parts of a game development program that you use to make games. They usually have user interfaces. They don't have to, but they usually do. So with Unity, it's more programming based. It uses C#, which is a programming language, which we'll touch on later. And with Godot, you have GD script, and it also supports a bunch of other scripting and programming languages. That's actually new to the scene. I think it's made by a guy called Yuan. I can't remember his last name, but he's basically just been working on it himself with like a skeleton team of people giving contributions. After the debacle that happened with Unity, a lot of people actually put funding into Godot, so it's actually kind of had like a explosion of features and support, so I would recommend taking a look at it. But it is also quite complicated to get into, I would say, as a first engine. So in conclusion for this section, you want to think about your ideation and inspiration, make sure you're doing your research, get your essence statement down so that you've got that core focus, identify your systems and mechanics so you know exactly what you're doing. You want to rescope and change your game's bounds to make it effectively more perfect, more well-rounded. So go big and kind of cut it all back until you've got something tiny. And then once you've done all that, do some research and look at your game engines and just see what is interesting to you. So here are some resources. I will actually share these slides at the end of the talk. I've just got these resources at the end of each part of this. I just think they're really, really helpful to have, and I know I definitely use them a lot earlier in development. And there's a few here that I wish I had earlier in development for games that I was working on. Like Masahiro Sakurai recently has started a video diary series over the past year where he talks about all the games he's made. He did Super Smash Brothers, he did Kirby. He's very established and knows what he's talking about, so definitely recommend, especially for game planning. Okay, so section B. game design. So what's next? You've done all of your planning, right? And isn't that what a designer effectively does? Well, no, not really. 'Cause, designers don't just come up with ideas, they also and they go through the ideation process for sure. It's all about problem solving and specifying what your project is for the sake of the player, effectively. Just going back to this very quickly, if you imagine someone who designs furniture, they're not just coming up with the idea like, oh, I want to make a chair, and then the chair just appears. They've got to specify dimensions, the material it's made with, how comfortable it should be, its purpose. Is it an office chair? Is it a lounge chair? And that is effectively what the designer will do. And then they'll have people sit in the chair and see if it's comfortable or if it's suitable. And if not, they make changes. And then they release it to the public. So that's effectively what you're doing with games as the designer. So you're like involved all the way through the process from the start to the end, which is known as the iterative cycle. So iteration is doing something over and over again. So once you've got your initial plans from part A, you're going into part B, which is the design, where you will then implement things, you test them with your audience, and then you can either finish that feature or finish the game, or you can evaluate it and go back into basically problem solve. So a way to really think about this is if I'm designing a feature, say like a grapple hook. I design the grapple hook, I know that I want it to anchor to certain things, I want it to anchor to trees, to ledges, to other players. That's great. It gets implemented, but it's not quite to the liking of players. Players think it's too clunky to use, that it's too sluggish, that it takes too long to use, that it has too much of a cooldown. And then that is what you've taken as very valuable information in the testing period that you're going to evaluate and then go back into design to refine those things. So you're not just throwing everything out and starting again. You're just tweaking those values, adding to it, and maybe even just making notes to the programmer in your team if you are working in a team, or maybe to just yourself, saying, hey, these are the things that need to be changed. And then they get changed, you test again, and you see if it's good enough. If it is, you can effectively ship it or move on to the next part of the process, a different game mechanic. Game mechanics are a part of game documentation as well as all the other things we spoke about before. I would probably say early on in the game design part, once you've kind of got your ideas down, I'd recommend starting a document, like a game design document. Take all of your ideas that you previously had and formulate those in at the start. So if you can see here, I've got the high concept document. That's where I put all those concepts at the start, including your USPs if you're doing a business thing, but this isn't about business, and your design pillars. And then you kind of just work out from there. You get more complicated. Okay, I want these things to have, I want this to last 3 seconds. I want this to last a much longer time. I want the game itself to last, X, Y, Z, and we'll talk about that as we go through this part. You don't have to have a word processor though, and I understand that Office 365, the Microsoft Office, costs money. You could just use Notepad. Like, there's also Notepad++, which has some formatting from what I understand. But when I was growing up, I would use GameFAQs for game guides to get through games. And if I can get through a game using a Notepad document, I'm sure I can plan a game using a Notepad document, is basically what I'm saying. Don't worry, you don't have to spend money to do your planning. There's a few design frameworks that you can look at too. You've got MDA, which effectively means you get your mechanics, which is the rigid parts of the game, the things that don't waver. You've got your dynamics, which is effectively your systems. And the aesthetic is what the player actually perceives. So that includes game polish. So for instance, you may have your particle effects and lighting, sounds, things that make the experience feel rounded. But one thing that was noted by a few people is that it didn't include narrative, which I understand a lot of people now want to make games so they can tell a story, right? So DDE was invented, which is Design Dynamics and Experience, which is basically the same thing except wagering in narrative. There's also the RTLSys framework, which is more about player motivation. So what makes the player tick, what makes the player want to continue, and you're kind of analyzing it through that. And my favorite of these four is the Bjork and Holopainen activity-based framework, which is this game component framework you see down here. The reason it's my favorite is because it is so, like I said earlier, holistic. It sees the entire project in all different kind of facets and brings them all together, and then you can use them to begin a document, which I've done here for a horror game idea. This would be like super early, so these are when you would just be taking notes, but then you would start to like turn these into headings and fill them out, and eventually you have your document taken from this. So it's a good lens to have. Kind of going a bit further into documentation stuff as well is your gameplay loops, which is understanding that you do a thing to do a thing. So in Minecraft, you get wood to craft a bench, to craft more things. That's your crafting loop, right? Material, craft, more material. And there's a lot of these as well. So here's a few that I'd actually made myself to identify those own gameplay loops. It's good to have these because players like loops, they like patterns, they like to be able to expect things during gameplay. If you're constantly confused whilst you're stumbling through a game, it's not going to make for a fun experience. So having an element of predictability is really, really important. So make sure you're identifying, even if it's your combat in a game like Overwatch, that you spawn, you kill enemies, you die, you respawn. It's like, and kind of beginning to specify out. From here, you can get a lot more complicated with it. So you can start to look at systems design, which is a lot more complicated than gameplay loops. On the left one here, we've got effectively systems which are bracketed into your planning, your activities, rewards, post-rewards. So different blocks of it, and inside of that, you've got your different mechanics. So it shows a flow to how things actually work and all the different possibilities that you actually have whilst you're doing things via your mechanics. The one on the right, though, is a much arguably easier way to kind of go about this. So that is, again, Animal Crossing, as you can tell by the town rating and stuff. Here I've just used verbs and nouns and not really thought about it mechanically. We're just thinking about how everything connects together. So as a result, you have a much simpler thing. So if you are new to design, I'd recommend taking this approach because it's actually kind of a breeze to do. You can also, like I said, go much more complicated. So here we've got individual systems, your decoration, economy, traveling, NPC, and town rating system. And they all feed into a hypothetical train service system, which you could really call a sub and super system. So like a system inside of a system, and then having those mechanics inside of those systems. You don't have to do this, but I think this shows a good sense of relation between all of their systems and how they work together. When you are planning and your game begins to get like behemoth in size conceptually, it's good to think like, oh, the grass burns and there's these enemies that are, you know, a fire type thing, so they're going to burn all of the grass and create a forest fire throughout my entire game. That's maybe not good. That these two things cross over in a way that I didn't expect. That is referred to as an emergent behavior. You do see emergent behaviors a lot in games. The new Zelda games, Breath of the Wild and Tears of the Kingdom, are all emergent based. Kind of a lot of that is like maybe not unintended, but definitely not like a forethought, and they just realize, oh, you know, like the things that are made of wood catch fire. There's a lot of things made of wood. Link's weapons that are made of wood will catch fire. It's quite interesting to do that, but it can also not be a good thing. So you may have heard of duplication glitches in games. That is an emergent behavior which has come as a result of a bug. Or sometimes it can even happen not because of a bug, but you can duplicate items because one shop vendor somewhere may sell an item for cheaper than they sell it somewhere else. So you can buy it from one place, fast travel to the other place, and buy more of it. Which is a positive feedback loop, but it also breaks the experience because then nothing has any value anymore. You also get negative feedback loops, which do the same thing, and you can effectively end up soft locking the player out of an experience or just not being able to finish the game. So your systems relations are super important to making sure you kind of catch a lot of these things early on. Understandably, you will probably come across them in game testing anyway, because this isn't a completely concrete way to do it. There is no concrete way to do it. There will always be issues in game development. So next we look at 3Cs, which is your character controls and camera. These are just ways to actually specify exactly what your player character can do from 3 different aspects. I think it's just kind of like nice to be able to do this really, because it just allows you to envision exactly what you want the character to be doing before you've, again, done any programming. It's hard to specify, especially if you're doing it in 3D space, unless you can draw 3D. But typically I just like to do side views or top-down views with grids. As you can see here, I've got 1 square is 100 units. Just because it gives you that sense of proportion, that sense of scale. You don't really need it to be 100% three-dimensional if it's a 3D game. On the other side, you can go a bit more specific here. So I've got statistics, which are metrics, and using things like mathematical curves to kind of express things like motions or how something might behave a certain way for. So for instance, if you have something that glows, you might want to draw like a bell curve kind of a graph to express that, so you can then hand that off to your potential programmers, or you can use that yourself later on to be like, oh yeah, this is what it did. Another way you can do this is just like look at other games and get a point of reference. In this top left one, I looked at the horror game PT, and I looked how the view bobbing worked. So I implemented that into my own game by attaching the camera to the actual model of the player. So when the animation would bob up and down, the camera would bob up and down. But I've obviously used someone else's game as a reference for that. So it's okay to use references. Don't feel like you're stealing an idea. Everything is a remix of a remix. It's just how things are. Maybe an extension of the concept of a game camera, but the UI and heads-up display here is in effect layering on the camera. Like it is drawn to the camera, so I would consider it to be a part of the 3C's camera. Not everyone does, and that's fine. There's no right or wrong way to go about this. But either way, this is diegetic, which means non-literal, and diegetic meaning in the game world. So you can actually see two examples here of Resident Evil 3 and Dead Space do them in totally different ways. They're both valid, and you just really have to think about what fits the tone of your game and what you're really trying to say with that. So I think with Dead Space, the reason why it's all diegetic in world is because it just gives you no moment to breathe. Even when you're in a menu, you're in the real world. The game doesn't halt, the world doesn't stop around you, and it creates a sense of tension. So that's quite valuable to the game's experience. You don't have to do that, and I would maybe argue that the one on the left makes you feel like a super cop, which is maybe what Resident Evil was starting to veer into in its once it kind of passed its infancy as a franchise. So either work, I think. This is known as a wireframe. This is actually from my own project. It was a Silent Hill remake prototype that I was working on. You effectively will like draw out what you want your UI to look like and just label it so that you just have it on hand when you're actually implementing that into the game. Here is an example of a menu, and here's an example of the heads-up display. The heads-up display is the UI that is drawn to the screen or drawn to the game world at runtime, so when you're actually playing the game. So the reticle that lets you aim, I'm not sure if anyone plays any shooters here, but that little thing in the center. So for storytelling, your game might not have storytelling to it, but that's okay. I'll talk about that in the next slide. But for the time being, basically, if you are telling a story, I'd recommend starting with post-it notes and go left to right all around the walls of your room, just with elements of those stories. The reason I suggest doing it that way is because if you notice certain story beats of your game don't fit, instead of copy and pasting and moving stuff, you can literally just take the sticky note off the wall and stick it somewhere else, and until you have like a solid thing, almost like a writer's room, and then eventually you can kind of formulate that into your game document as a solid idea instead of putting your ideas for your story into the game document and confusing yourself. I confuse myself all the time doing that. If it's a much more visually kind of driven game, so for instance something like It Takes Two, where it's got a lot of cutscenes and it's really trying to characterize what the characters are, you can use storyboards to get that idea across. You don't have to be good at art to do storyboards at all. You can do something referred to as thumbnailing, which is where you just take really small blocks and just scribble in them. And as long as it makes sense to you and you've got some notes there, I think that's fine. You're not trying to, be Picasso or anything. Another really good tip, which I actually found from Yoko Taro, who did the Nier series and the Drakengard series. He started with writing his emotional peaks. So for instance, your character deaths, the end of the game's story, and working backwards from there to find the reason for why that happened. So he didn't know himself why characters died. He just knew he wanted a character to die to create a dramatic moment, and then he'd work backwards to find the reason. which then from the player's perspective feels more justified because there's been a build up to it, right? And it's easier to plan a build up working backwards than it is forwards. So like I was saying before, your game might not have a story, but it certainly has scenarios. By scenario, I mean like when you're going from the start to the end of a level, or you're progressing through a game world. And that is what I would refer to as your scenario. This on the left here is how Nintendo plans their scenarios for their games, or plans their levels and how they flow. It's a Kisho Tenkatsu, and it basically is just like a 4-part narrative. I think it's better than the hero's journey, which is, Todorov's theorem of hero, or whatever you want to call it, where there is an implication that there is combat there, because your game might not even have combat. You might be making Viva Pinata or something. So let's first look at this in terms of Mario. Mario will introduce a stage and it'll introduce a concept. So for instance, the first stage introduces that you can run right, sorry, and that enemies can hurt you. And then as you develop, it introduces new enemies, it introduces pitfalls. So you're not just jumping over obstacles now, you're jumping over pitfalls that can actually kill you if you fail to jump. And then at the end, there's the big twist where you can go either underground, or there is multiple levels that you can walk on. So like a top and bottom side that are split by blocks. And then obviously your conclusion is jumping to that flagpole and getting that satisfaction. For a game like Viva Pinata, for instance, which is a virtual pet sim, so think like a Neopetsy Sims like kind of game where you raise pinatas. It will introduce a pinata to you. It will like come to your garden, and in development you effectively do, you get it to like stay in your garden, and then the twist is that another animal in your garden might need to eat that in order to be romanceable with another of its type, and then in conclusion you make your decision, right? So they're all scenarios. I would technically consider the overarching structure of all of your puzzles in a game to also technically be a type of scenario design. So here we've got Amnesia: The Dark Descent on the right, which is your going through your acts, and but in each of those acts there's one major puzzle, which effectively gives a sense of flow. So like if you do want to plan your scenario designs, just do it like that. It doesn't have to be complicated. It can be really straightforward. Going further into puzzle design as well, Scott Kim has the 8 steps of puzzle design, which I've used myself when I've done my own puzzles for games. The reason why it's good to do this in prototype, which I will talk about prototyping later because it's super, super important to game development, is you just make sure that everything works properly. There is nothing worse than a puzzle that doesn't make sense or infuriates the player. I'm sure everyone here has played a puzzle game where they've been stuck for ages and it's felt unjust and felt like, I should have maybe known this. That's not fair. The game Secret of Monkey Island has, I believe, you collect a monkey and you've got to use the monkey to open something because it's a monkey wrench, and it's like, how would you know that? It's absurd. Not everyone calls that kind of wrench a monkey wrench anyway, so it's like you need to be a very specific kind of person that calls that specific kind of thing that to understand it. So it's like all these different steps of understanding, constructing, defining, making sure everything's together. Make sure your puzzles are like solid and work. Ron Gilbert, who actually worked on The Secret of Monkey Island, is very critical of his own past work and speaks about his work on his own website, grumpygamer.com. He's actually an excellent designer, and similar to Yoko Taro, he works back to front. So, for instance, he has a puzzle. This is from my own game that I did a little while ago. You have your door, which needs 2 different kinds of keys. I knew that I wanted a door that needed 2 kinds of keys, so I kind of worked backwards to realize like what kind of keys they are, what you need to do to get those keys, so you have a sense of variety in your game and it's not just a linear experience of get item, use item. I just recommend doing it that way, really. Going on more into level design, you've got your breadcrumbing and the other means of affordance. In the left one here, you can see coins used in Mario to kind of guide the player through from one area to the other. Sometimes in a game, you might notice during testing, a route just isn't obvious to the player, so you can use breadcrumbing in the way that Mario uses it here to make sure that the player knows that that's a route they'll go, because they'll go to collect the coins and realize, oh, there's something over here. You don't have to do it as literally as that. You can actually kind of do it a bit more obfuscated and a bit more sneaky. But you can do it either way. The more hotly debated one that you can see on the right here is the use of yellow objects in video games. At the moment, a lot of people are very up in arms about this. I think for a sci-fi type game, it's acceptable to do this because it kind of fits the aesthetic and fits the theme. And I think really that people are trying to comment that the bright, vivid yellow colors do not fit either the color palette or the vibe and theming of the game that they're put in. So just be conscientious of that whilst you're designing these kinds of things. But remember, just because everyone's upset about something doesn't mean it's actually the wrong way to do it. There is definitely a part and place for everything. Looking at scale and reference for level design is also very important, as you might realize during testing, if you don't do your scale and reference, that the player is way too small or way too big and can't fit through doorways, for instance. So make sure you get your player scale early on before you actually go into your level design so that you know what you're working with and you have a point of reference of how big things like, for instance, like I just said, your doors should be, how big areas should be. And even something like the, this isn't really scale, but the FOV, like the field of view of the game camera as well, really determines how vast a space might look. So if you're doing the 0.5 camera thing on your phone where you take a picture of someone's face up close and it like dilates or distorts the image, the bigger your FOV is, the more gigantic and kind of distorted something can look, or how small it can look, which can make rooms look bigger or smaller. So sure, it might from the viewport look like that room is the proper size, but does it look that size in game? Testing game as well. On the right here, we've got the dimensions of furniture in the IKEA website. The reason I've put this here is because a lot of game engines will use 1 unit in their game to 1 centimeter in terms of measurements. So if you want to know like, oh, you know, I need a table and I need to know how big the player should be in correlation to things, literally just go on the IKEA website and just look at the size of furniture because it is just such a useful tool to have just measurements. It works. So assuming you've got your scale, you've got the player, you've got your cameras and everything all sorted out, and you know exactly what you want to do, you would then go into the process of blocking out. What blocking out is all about here is just placing basic geometry in a way that fits the vision of your game. You do this before you've actually included any art. This is The Last of Us 2's blockouts from before it's actually finished as a game. And right. Yeah, basically you then replace it with art later on, but the game designer doesn't have the onus to be placing that art in. It gets placed in by the artists later, usually. Yeah. And here's set dressing as well, which is effectively the back end of, like you see here, it's been set dressed. They've put things in there to make it feel more like a world and less like a game, which is very important. You also get focal points and leading lines. Journey always has this mountain, which is a vantage point. So it's like, you need to go towards this. It's like, always head towards the mountain. And it acts as a guide for the player. You get less literal ones, but it acts as a stand-in for the hero's journey, effectively. Leading lines on the right there are basically just telling the player, hey, go here, but instead of using an actual thing you're looking at, it's using the lack of something to go towards. And horror games actually do the inverse, so you get doors, which are kind of the focal point of the scene, so kind of like an actual focal point, but it's more so like, don't go here, it's scary, it creates tension. You can also use the inverse, so on the right here you've got a map of a game that I worked on, where the leading lines for the hallways actually showed corners all the time, so no matter where you were really stood, you could see like around a corner, but not actually be able to see what was around that corner to create a sense of tension through the player not being able to see things. And then lastly, we've got loops and navigation variety. You don't want the player just going the same loop all the time, so it's really good to have these kinds of things like figure eights, literally just from like room to room, or even within the same rooms in a game. For satisfaction, a game like Dark Souls will have a locked door early on in an area, and once you've gone through the entire area, you will unlock a door only to realize that's the same door you saw at the start, and it's created a complete perfect loop, which is very satisfying to the player. So try to include those when you can. So yeah, in conclusion, these things, basically just the things that I just spoke about. So, your specifications, make sure that your level design is rigid, make sure you use your scale, um, and just make sure that you are documenting everything and using frameworks as a way to kind of look at things as a holistic whole. And again, here's some resources. Let's quickly go into development. So you've got all of your designs, you've got all of your parts together, but you've not actually structured them into anything yet. So what do? This is where prototyping comes in. It's a really helpful tool for actually problem solving and working efficiently by failing often in small ways. So, for instance, you might want your, like I said earlier, a grapple hook mechanic, and you would prototype that to then see if that works. In the prototype, if it doesn't, and it's failed and it doesn't fit the vision or it needs tweaking in some kind of way, then you know to do that and then you can put it in. So here's some prototype examples of games that I'd worked on previously to just show how simple that you can really go with your prototypes. In this one, it was just showing that I had the walking mechanics in, that I had atmospherics there, and that I was able to pick up items. So you can actually see in here, I pick up a flashlight, which shows the item pickup, and it wasn't perfect, but it got the point across for what I wanted it to be. So I can use the flashlight, and in the right here, you'll see that the inventory opens up, so it shows the inventory system too. And if you aren't confident in programming by this point or scripting, you can also just do paper prototypes instead. So imagine your game is a tabletop game. And you can do that like this. It's very rudimentary, but if it gets your point across that it's fun to play with your players, then why not, right? There's two different kinds of ways that you can look at the scripting for games. You've got your visual scripting, which is effectively like taking nodes. It's like a simplified, distilled version of your programming. And it exists for people who are either beginners to or don't understand something referred to as syntax or don't care for syntax. Syntax is how your programming is correct, effectively. So use like a squiggly things called braces. And if you don't include those, it breaks things. But you don't need to worry about things like that with visual scripting. So it's probably, I would say, is pretty beneficial to people who are starting out. And I would maybe recommend you start with that so you can understand those core concepts before moving into scripting. Unless you are confident with scripting, then, what you want. Unreal Engine and Unity both have their own versions of visual scripting. So Unreal Engine has in the top one here, you can see blueprints. And then in the bottom one here is Bolt, I believe it's called, or it's now called Unity Visual Scripting. And like I said, it's just a simplified version. Whereas your text-based scripting and programming is the one that you can see on the right here. It's using something called an IDE, which is basically what you program in when you're making games that are script-based. But it's all the same, we've got all these different things. I'll go through the anatomy of this in a second. So here we've got the IDE itself. It just kind of shows everything there. It really is basically just like Notepad. And yeah, going into the actual concept of what scripting is, we've got constants and variables. Constant is a data type that doesn't change, whereas a variable is a data type that is changeable at, at runtime or whatever. So for a constant, you might want the number of levels you have would be a constant potentially, whereas a variable would be like the player's health or how many bullets you have in a gun. You would use integers, floats, characters, strings, and bools. For these, there is also like so many different types of data types as well. Some engines do have unique data types, but I wouldn't worry so much about that. You kind of learn as you go along, so just like experiment and see what suits you basically. But I think a good way to do this is to give yourself like little mathematic challenges using, like a visual scripting language to understand how they work. You also have references, which is a data type which is like saved effectively to be able to be referenced. So for instance, you might have a reference to the player, and the player is a data type of a class, and you can then use that to cause damage to the player or give that player an item. There's also data structures, which is a collection of data types, which are the ones that we just looked at before. The most general one is a struct. You have a class, which is a type of struct, from what I understand. And you've got vector 3, which is usually your position in a game world or a position in a game world. So it's like a X, Y, and Z. Some engines don't natively have things like vector 3 in there, and you have to make a data struct from a struct yourself so that you have vector 3. And then you've got transform, which is your position, rotation, and scale. Again, you can use it to really just store 9 different values if you want to. And the last one that I think is super, super helpful to have is arrays. You decide a size. Imagine you have a box and you fill them with your data, but you can only put a single data type in there. So if your array is of a type of player character, you can basically fill your imaginary box with player characters up to the size that you have. It's worth mentioning as well, it starts from 0 and not from 1. So imagine you've put things in that box, they're effectively labeled, and when you take them out of that box, you are looking for a label. So they actually go in the order that you put them in, technically. You got operators, which is just standard mathematic. It's pretty simple. I think everyone knows what these symbols are. And then you've got statements, which is true and false. These are your if statements, for each, while, and there is a bunch more that you can do as well, but I think these are the ones that you really just need to know from the get-go if you're making your first game. So the anatomy of a function, you can see here I've made a function called run the math, and it takes, what you can see in the red section here is 2 arguments for 2 integers, which is referred to as a and b. Then inside of that function, I can then reference a and b, and it'll know that I'm talking about this argument here. I've also created something called a local variable, which is a variable which is stored inside of a function and is only viewable within that function. So here we've got a and b is equal to that value. And once we return that value to here, you can see that it creates 5 effectively. So 1 and 4 here, 5. There is other concepts as well, like inheritance, which is where you have like a major class. So for instance, human could be your class, and then everyone is of type of a human, but they're still their own classes inside of that, if that makes sense. You don't have to do this. I would recommend doing it. And another one is interfaces, which is communication between 2 different game objects without the need for a reference. So you might want to damage the player, but you don't need a reference to the player, because the player and the person damaging the other thing damaging the player both have that interface, so they know that they're able to communicate. So here's an example that I've used myself from one of my own projects with a card sorting system. You can see in blue, all of these are data types. You can see in green, all of these are functions, and you can see in red, all of these are statements. This is actually adding and removing from arrays, so there's imaginary boxes that I was talking about, and doing very basic maths. For instance, this one here is called hand size, and it's just a whole number integer. And once you add a card here, it just adds +1 to the thing and updates that. So really, scripting is not that complicated. It gets a bit like noodly if you're doing visual programming, especially. But it's just, keep your stuff tidy as you're going along. And here is that in game as well. So just the card-based system. Optimization is not really something you need to worry about if you're doing prototyping or making your first game. Don't worry about file sizes too much, and don't worry about your game's frame rate. You're not trying to make Call of Duty. It's fine. Just have some fun and experiment. One thing I will mention though is the KISS principle, which means keep it simple, silly, which is effectively, if you have an idea for a system, try and keep it as simple as possible when you're implementing that. You don't want to go all out and be like, oh, it needs to have all these different things and it needs to be sorted through all these different algorithms and stuff. It's like the programming that you see in the movies and in TV shows is so far from what you actually do. A lot of programmers do tend to take code snippets online, which is like basically copy and pasting code from documentations as a way to start, because they know how to do it, but it's so much more efficient to be able to copy and paste those in from documentation, and even just like taking from their own code from older projects that they've worked on, because it just saves you so much time doing it that way. So all across the board, just keep it simple. One last thing I will mention as well is you have collisions, which is how things actually know that they're touching in a game engine. They're basically boxes, spheres, and capsule shapes. Um, and everything in the game world is made from these. You will see colliders everywhere. You may have seen screenshots of games in development with boxes all over the screen. They are likely collisions. Collisions are used with physics engines. So every game has a physics engine. It basically allows it to move, navigate, and so on and so forth. When you're doing your stuff, just make sure that you're Googling a lot. A lot of people I know are like, I don't know what I'm doing. I don't know what to do. Just learn to use Google effectively, and especially use forums. Use Discord servers, forums, everything that you can use in your power, because everyone else is there to help you, and you should also be there to help everybody else. So in conclusion, again, prototyping is super valid. Keep it simple. Only optimize when it's absolutely necessary. And physics engines will just make development less scary, because you don't have to program the physics yourself. Those physics engines are there to facilitate a lot of your movement and things like ragdolls in games. You don't have to like make your own ragdolls effectively. Again, here's some more resources. Now let's quickly go through asset creation. So if you're not an artist or you have no interest in art, that's kind of fine. It is a complex skill, but it's not needed to make games. So here's some programmer art you can see in Minecraft and Thomas is Alone. It's super rudimentary, but it still communicates the points across, which kind of gets my point across. You don't need to be good at art to visually communicate something well. So just practice making sure that things are visually readable. However, this section is for art, so even though I'm not fantastic at art, these are two games that I did the art for myself. This section is just for those people who do want to do a little bit of art. So here is one called Photopea, which is free to use. It's for 2D art. You can use it for texturing as well. Texturing uses something called PBR in a lot of modern game engines, which means photorealistic based rendering. So you tend to use all these maps, but older games tend to use something just known as a diffuse or a bump map together to create much simpler textures before we decided we wanted everything to be photorealistic. This is known as non-PBR or non-photorealistic based rendering. And it basically gives you a non-realistic look to your game. So if you want to go for stylized games, do not use PBR, just use a non-PBR workflow because it's much easier to work with. You also have your materials and shaders, which kind of determines how a game actually looks. So that's taking all of those textures that you see in the previous slide and formulating those into what you see here on the left is a photorealistic material, and what you see on the right here is non-photorealistic materials and shaders put over the top of things to give these harsh edges and shadows to things. That's actually a technique referred to as cel shading. You can also get a free free modeling software like Blender, which is really good to use, which is made of things called mathematical vertices, which is much like a three-dimensional graph. So you've got like your X and Y axes, and you've also got your Z axes going out. And all of these points are plotted in that space, and then they're drawn together with something referred to as edges, creating tris and polys to then create your 3D models. So here you can actually see a wireframe which includes all of these little vertices which connect the lines together to make a character. These are some characters that I made back in 2021 for a little game for the GMT Game Jam. I started from initial concept here, just a little pixel art thing. So again, programmer art doesn't have to be complicated. I just drew some textures and it just made a cube and drew a face on it and made little bodies for them. And I think it worked really well for something that took me like half an hour to do. And that is something that you can do too. You do not need to be good at art to do these kinds of things. So is there anything else? Yes, you've got sound. You can use JSFXR to make your own sounds for free. You can also use Audacity, which is a free audio tool to do things. You can just record sounds on your phone, or you can record them, with a laptop microphone even. It doesn't matter if it's bad, and then you can do things like EQ balancing or just cutting the noise out of it to get the sounds exactly that you want. Or you can even use a website called Freesound and then put those into Audacity to clean them up or pitch shift them to make them sound exactly how you want them to sound for your own games. There are also sound engines kind of similar to physics engines in games that do things like calculating sound bouncing off of walls to create like echoes, things like attenuation. So this is just showing Unreal Engine's meta sounds and showing Unity's sound audio source sound engines. For sound optimization, I know I said not worrying about file optimization before, but when it comes to sound, I definitely would make the difference to save your sounds as OGG and not as WAV, because WAV is uncompressed, which means it is a way, way bigger file size, and you'll end up like going into the gigabytes if you have entire songs that are just like WAV put into your game. So in conclusion, art's complex to master, but anyone can do it, and you certainly can do it. Art will not make a bad game any better, so don't worry about that too much. Shaders are a deciding factor in how a game actually looks, so think about your cell shaders, your PBR and non-PBR workflows. Everything is made from vertices, and ultimately you have a lot of other aspects to it as well. So you've got particle effects, simulations, lighting that you can also go into. It's a very dense subject, but there is a lot of things online. For instance, Ace Rolla and Raw Skies specifically are a godsend for graphics resources. So just like take a look at those if you want to have a better understanding of these kinds of things.